Page 43. Right, application. Of right, on task. Let's go. Application. Alright, so we're going to first look at angles of elevation and depression on page 43 of your notes.
Quick question, sir. Does the past HSC count towards our overall grade? Does it have an weight?
No. But it will count towards your report comments.
That's alright.
Do I just put... Or leave here?
Yep. Alright, so we have all seen angles with elevation and depression before. So, elevation is the one going up from the horizontal. Come on, you lot, listen. Alright, so horizontal line, like the horizon, goes left to right. Okay, and the angle of elevation goes up from the horizontal. Okay, now it's different to the angle of depression. Okay, where you've got a horizontal line, so there might be a plane flying
Straight down.
from in the sky, or someone looking straight ahead off a lookout. Okay, for example, okay, the angle of depression is the angle going down, and it's not in the actual triangle from that perspective. Okay, however, these two are parallel lines. Okay, and then you all know your alternate angles are equal on parallel lines. Okay, so going back to geometry to apply for your trig. Okay, so that'll be the angle in that triangle there. Alright, let's look at some examples. Cooper is 50 metres away from the base of a building. So he looked up and he sees Matt and Bree on top of an 80-metre building.
Did you do that about the Year 12 class last year?
I would have made it up after that. Alright, so what is the angle of elevation from Cooper's view to his friend to the nearest minute?
That was smart if you did, sir. So you didn't actually make that up? No, you didn't.
You so did.
Yeah, you
No one's named Bree.
Yeah, there are so many people named Bree.
But it had to be with Matt.
Bob.
It was.
Man,
Matt.
yeah, no, I'm not saying it's
Make
wrong,
up.
I'm just saying so many people named Bree.
Yeah, that was cool.
Anyway. Alright, so step number 1, draw a diagram. Okay, it's a right angle triangle, trig. So he's 50 metres away from the base of the building. Which part of my triangle is that referring to? Flat bit on the bottom. Okay, so part of your skills is you need to be able to draw a diagram, put the information in the question into the diagram so that you can answer it. Alright, he looks up and he sees Matt and Bree on top of an 80-metre building. So which part of my triangle is that referring to? 80 metres there. Alright. What is the angle of elevation from Cooper's view? Okay, so he's down here
He's under the ground.
from his view.
He sees from his feet.
Okay, that could be the base there, couldn't it? Alright, so that brings up a very important point actually, because there's no other information in the question regarding Cooper's height. Okay, so we need to actually treat this like the right angle triangle there is, because there's no additional information. Okay, so we need to ask the angle of elevation, so we're finding that angle there. So what is the angle of elevation from Cooper's view? So from Cooper's perspective up to his friends on top of the building. To the nearest minute. Alright, so when I taught trig last year, that nobody was in my room when I did it. Okay, I did this in 5 steps. Okay, so step number 1, draw and label a diagram. Okay, step number 2, label your 3 sides of your triangle. Okay, so you go from the right angle, opposite side of the hypotenuse, from the marked angle, opposite side, which is the opposite, and the leftover side is adjacent. Alright, step 3, pick the correct ratio to use to solve for the variable. Okay, so I know how long the opposite side is, I know how long the adjacent side is. For this particular question, I am not going to use the hypotenuse. Alright, sine, cos or tan, which one uses O and A? Alright, so you need to know your SOHCAHTOA or however you're going to remember it. So tan theta is O over A. Okay, that's step 3. Step 4, substitution. Tan theta, so that's the variable I am finding. Okay, which equals the opposite side, which is 8t, and the adjacent side, which is 50. Alright, have we done an example where we solved for the angle? When you're solving for the angle, so you need theta by itself, so you need to move that tan over to the other side, and it becomes a tan inverse. Now those couple going in general, yes, you'll be doing this sort of work in general as well, okay?
Couple. Yeah.
Guys,
Just 2.
come on.
No,
If you don't get first in class, if you both don't get first in class,
Right. Now using your math skills here as well, okay, I can write 80 over 50 as 8 over 5. Okay, less I need to put in the calculator.
57.9.
I can erase 80 over 50 to become 8 over 5. Okay, so what do we get to the nearest?
7 degrees and 59 minutes.
What was it?
58 degrees.
57 to the nearest minute I need.
Oh,
Just 59.
57 degrees to 59 minutes.
So 58 really, but the other
And nearest.
Okay, so yes, the minute itself doesn't change the overall degree. Okay, yes, when your perspective is much more further, yes, it will make a difference. Okay, but we all need to know how to round correctly to the nearest degree or minute, and there's an exercise that will look after that at the start of chapter 6. Alright, any questions there? Alright, part B. So, Blake cast a fishing line, 45 metres, from the water's edge on a horizontal line. If the line makes an angle of 42 degrees with the water's edge, we need to work out how long the fishing line from the tip of the rod to the water's edge to the nearest centimetre. Alright, so, right angle triangle. Okay, don't worry about your dimensions and your scale, alright? Just as long as you've got the right angle triangle in there somewhere. Alright, so he cast a fishing line 45 metres from the water's edge on a horizontal line, okay? So it's not referring to the slant, alright, he's referring to that horizontal line there, okay? So here's the water. Okay, that's the water's perspective.
45 metres. That's a tank. What a beast.
So if the line makes an angle of 42 degrees, okay, so that hypotenuse will refer to that fishing line, and this side here will probably refer to the fishing rod, okay? And yes, it's not to scale. So how long is the fishing line from the tip of the rod to the water's edge? So this is the variable we need here. So I'm going to call it X or whatever letter you want. Whatever you want. Okay, so step number 1, the diagram's done. Step number 2, label your 3 sides. Okay, hypotenuse, opposite, adjacent. Step 2 done. Step 3, decide the ratio. So I know how long the adjacent side is. I know the angle inside the triangle, the variables on the hypotenuse, and I have nothing at all on the opposite. So on this particular question, I'm not going to use the opposite. Alright, sine, cos or tan uses adjacent and hypotenuse. Alright, so cos theta is equal to A over H. Okay, so a question like this probably worth 2, maybe 3 marks. Okay, so next step, substitution. So theta is the angle inside the triangle, which is 42 degrees. Adjacent, which is 45, and the hypotenuse, which is x. Right, so you either need to use your equation skills, okay, to get x the subject, or you need to remember that when the variable's on the bottom of the fraction, we swap it around. So that means x is going to be 45 over cos of 42. If you don't want to take my word for it, you can go and solve an equation for x. Because you all know how to do that, in theory. Alright, so we need an answer, and we need it to the nearest centimetre. Alright, so putting that in the calculator and thinking about your answers.
60.55 meters.
No, you put the centimetre.
Oh no.
You put a hole in the beam.
Yeah.
Okay, so the units in the diagram are metres. Okay, so when the answer is requiring for you in centimetres, you can do one of 2 things. You can convert that to centimetres, or it is correct to 2 decimal places. Okay, because there's 100 centimetres in 1 metre, so that means 2 decimal places will give you that measurement to the nearest centimetre. Alright, any questions on that one? Alright, so no question? Part C, Luke answered this question. Looking at your diagram. The angle of depression from a helicopter to its landing base is 52 degrees. If the horizontal distance between the helicopter and the landing base is 150 metres, we then need to work out how high the helicopter is at this point. So, a diagram provided, an answer is also provided with the working. Okay? So, Luke has calculated the height is 117.2 metres. So, here's the diagram where it came from.
Oh,
Oh, he already learned about these. That's fine. And we'll call and say we're going to do it.
I knew, everybody knows.
It's gonna be hilarious.
Record it, please.
Alright,
Just record.
let's have a look.
Like,
Alright, so I'll read the question again, looking at the diagram. So, Luke answered this particular question. The angle of depression from a helicopter to its landing base is 52 degrees. So the helicopter's up here. If the horizontal distance between the helicopter and the landing base is 150 metres, then we need to work out how high the helicopter is to 1 decimal place. So, looking at that diagram, is Luke correct?
Yes.
Probably.
No.
Why not?
That's 117.
Because he calculated that I had one.
No.
Because?
You probably.
No. So who's gone? 10:52.
He did do 10.52.
Wait. What's the question again? Did he do the wrong one? 10 plus TOA went there. O.
Not from that diagram. But did he set up the diagram correctly? Let's go back to the first point.
Angle of depression.
Yeah.
Yeah.
That's silly, kid.
Okay, so the angle of depression. It is from the horizontal down. So this angle here is 52 degrees. Okay, not the angle with the vertical out to the slope. Alright, and then using the geometry skill, it is 52 degrees there. Okay? So Luke is not correct because he has not set up his diagram correct. Okay, but from the diagram he had selected the correct ratio, he had made the correct substitution, and I am assuming that that's the correct calculation. Okay, so that's the thing here. If you don't have that first bit correct, but they then show the evidence that you knew what to do next, you will get part marks for your question. Right? You're not going to get penalised because you put the wrong variables in there. As long as you're continuing to get it correct after that point, you will get your marks. Alright, so what should he have got for his answer if he has made an error? So let's work through it. So we know that's the hypotenuse, that's the opposite, and that's the adjacent. So he's got it around back to front.
Yeah.
So tan O over A, so tan is H over 150. Okay? So, you've got an example over here where the variable is on the bottom of the fraction, you swap it around with the ratio. Okay? If the number is on the bottom of the fraction, you bring it up and you multiply. Okay?
191.
Yep, before we get there, Robin, hang on. Alright, please watch and be careful how you do the next step. Please do not write 1052 times 150. Does everyone see why?
It's going to times that 150 as a degree.
If you don't have your calculator set up correctly with the syntax on your calculator, you're going to calculate 10 of the angle of 52 times 150. Okay?
No, they've finished.
They're finished in that plan.
No, but everyone's. The bell has to do.
Or can I finish this question first? Alright, so do not do this, please. Do this. H is 150 times 10 of 52. Alright, number out the front,
That,
multiply by 1052.
I've been hearing that all day.
Yeah, it was
I have not.
I want to break it.
Okay, so we've got to do bearings before you can do that exercise. Finish that. So it's important that your question's set up correctly. Alright, as you're leaving, I need all your exam papers and questions. Make a pile at the end of that desk there for me.